Hi, welcome to another exciting adventure in the Binding Status. This is the Crossplane bi-weekly, fortnightly uh, vlog, video podcast on YouTube. I don't think any of those words work together. Where we discuss Crossplane's latest developments and anything going on in the community relevant to Crossplane or Kubernetes and how those things tie together. So thanks for tuning in this week. And if you watched previously, thanks for tuning in then. And if you're watching in the future, thanks for tuning in that way. All of these streams are saved to our YouTube channel, which is obviously linked below this. And you should like and subscribe our videos to follow and keep along with that. So the things that we're going to talk about today are the Crossplane 0.3 release, which happened last week and introduced lots of new features to Crossplane, and we'll get into that in a moment. There's also a stack that I'm going to try to run through today. It's a Linode stack. It's going to be very rough around the edges, and but it is a nice starting point, and I think that it's something that you can that will show us all how to take a naive queue builder project, just following the cookie cutter queue builder path, and then inserting into there what makes a cross-plane controller a cross-plane controller. We'll also touch on cross-plane stacks and what it means to turn that controller into a stack. So I think it's also worth noting that the notes for this show will be linked below the video, but we also have a GitHub repo, github.com/crossplaneio/TBS, where assets for this podcast live, and readmes for each episode. So I may just link out to the GitHub project where this Linode stack is living right now, or we might just throw the whole stack right in there. It should be a good learning reference. I'm going to build on it a little bit as far as it goes in terms of being a learning tool. So let's go straight to the release notes. There we go. So 0.3 was released on my birthday, and happy birthday to me. Yep, getting started right on time, says Jared. This is correct. Bill is in Seattle. I'm in New Jersey, Egg Harbor Township, New Jersey. So we've got a 3-hour difference. It's noon for me, 9 o'clock for them. And I'm following along in the Crossplane Slack in #TBS, and also on the YouTube live chat. And if you have any questions, please ask them in there, and I'm sure somebody will answer it so quickly and accurately, more accurately than I will. So let's see, what are some of the features that came out in 0.3 and some of the differences? So the popularity of Crossplane has blown up. More GitHub stars, forks, commits. Our Slack is increasing in number. We've got more Twitter followers. We've made a bunch of changes to the project. We've removed out from Crossplane the individual cloud providers. So now there's a Crossplane. Thanks, Javad, for the happy birthday. We've got a stack AWS. We've got a stack GCP and a stack Azure. In each of these stacks is a driver that lets Crossplane interact with those clouds. So you can, for example, on all 3 of those clouds, provision managed Kubernetes services, managed database services, managed cache services like Redis, and storage services like object storage. And by moving those stacks out, we've essentially made it easier for new stacks to come into the environment, share the ecosystem, and we've separated out what makes Crossplane in terms of its controllers that it needs to do its job in Kubernetes, and these stacks, these infrastructure pieces, and then the backing piece of all three of these stacks, and Crossplane itself is Crossplane runtime, where we define some of the magic that makes Crossplane do what it does. We'll get into that in a little bit. Yep, and so we're excited to onboard more stacks from, say, Pivotal, Yugabyte. There was a tweet the other day from, that's not my tweet. There's a tweet the other day from Dan. There's so many Dans, from Hashit Dan, which is Dan Mangum, who's our usual host to this show. And in it, he got a packet driver, what are they called? Packet host, the packet host provider, which would provision one of their bare metal hardware, which is really cool and is a testament to the work that we've done now, that it's a lot easier to get a stack going like that. When I say a stack, it's our provider driver. Stacks also have picked up a few more features. They've picked up the ability to do inter-network connections. So if your Cloud SQL and your Kubernetes cluster need to talk over a managed network, you can configure that. And this is the same for Azure and AWS. This was one of the points that made our documentation, our walkthroughs sort of difficult, is that you had to pre-configure a lot of these things, and that's not the case anymore. We've moved it into Crossplane itself, and you can provision it the same as you can provision anything else. Yes, I'm using dark mode theme that Hashid Dan Mangum points out, called Dark Reader. I just, it helps the eyes. So yes, Stack Experience. This is the team that I'm on right now, with Jared Watts and Daniel Susskind, too many Dans, and along with Phil Prysak. This was our focus, was getting this Stacks developer experience put together, which meant adding features to the Crossplane Stack Manager, and also getting a CLI put together to simplify the process of creating, building, publishing stacks. Of course, what are you building and publishing? We had to define what that metadata is behind a stack and how that works. There will be more tools coming out in the next release focusing on this, so look forward to 0.4. I believe I've passed over a major differentiator between 0.2 and 0.3, and that's the docs. We've greatly improved the docs in Crossplane. We've got developer docs that we didn't have before, that do a great job of explaining exactly what it takes to make a Crossplane managed service controller, and defines all the pieces that are involved in that. I'm probably going to refer to this a few times as we're walking through this this demonstratable Linode stack, which hopefully demonstrates without too many explosions. I did want to point this out. I accidentally flipped to it before, but Upbound, where most of the Crossplane community developers work, is getting involved with GitLab to put forth the multi-cloud con. And so we're looking for a call for papers on that. October 7th, please hand in your papers, and we will be reviewing those. I'm not sure what the process is, but it's exciting. Upbound is in the world of multi-cloud and is leading the way. So I did want to get into a few more details. These are the release notes from GitHub about our 0.3 release. We've talked about how stacks have been added. This video stream is a new part of our new emphasis on developer experience. So this is living, breathing proof. And I should take a few more breaths, actually. The managed external resources, we've evolved the way that we work with our reconciler process. At one point, the three stacks that we have, they all look like they were written by different people, and they were, and they all acted very differently. And we've extracted from that the core recipe and put that into Crossplane runtime. And we're still in the process of updating all of the GCP, Azure, and AWS stacks to follow the exact same shape, but at least we've defined that shape now. So we're in a much better place there. Notable features of stacks. Yes, stacks do exist. I just mentioned that. I mentioned that we have our documentation now. This is about your binoculars. We have documentation for stacks. We have documentation for services. And API reference. This was brought to you by Nick Cope, Negs on GitHub. And these are auto-generated from the Go comments, I believe. And let's see, we can dig into it a little deeper. I think I ran into some little bugs before with this, but this is the first release of these docs. I'm sure they're going to get better in time. But this is another example of things that we've done in so the docs split functionality between cloud providers. Yes. Yeah, and we're calling them infrastructure stacks. We've realized that there's two different kinds of stacks that people are going to be interested in for right now, and that's infrastructure stacks, which represent cloud providers, and then there's application stacks that represent sort of like what we had with the Kubernetes application managed resource, where you want to have WordPress. You want to have WordPress deployed somehow, and you want it to take advantage of all these managed resources. You want it to deploy on Kubernetes. You want it to take advantage of a managed database service. And all that you want to do in the end is say, like, kubectl create WordPress. Now you're going to have to do that with a YAML file. I think you can only kubectl create core types. But kubectl create that and just provide the minimal configuration for that, taking advantage of the resources that you've already defined through Crossplane. So that's what an application stack is. It's going to be an easy way to deploy an application that takes advantage of the infrastructure stacks. Yeah, breaking changes. Sorry, there's a lot of them. Pretty much uninstall and install the new version. The Helm charts have been updated, so you can do it that way. You may have to clear out any old CRDs, anything that was part of the old release that didn't come out cleanly. You'll need to remove. So, okay, let's move on. So you've talked about this. Yep, there will be more to come in the next release, which we are all very, very busy scrambling to get together in the next, say, 2 months. So look forward to that. All right, let's hop into this Linode example that I want to put out here. So I've created a I should probably say I had a previous life at Linode. So Linode is a cloud provider that I'm very familiar with. I started the work on the Linode Go API driver. So by working with a cloud API that I'm already very familiar with, and an infrastructure I'm already very familiar with, and taking using Crossplane stacks, which I'm familiar with, I could use what I know to maybe outweigh the things I didn't know, which is all the improvements that came along in the latest version of Crossplane. So I've created a little account here. It's got nothing in it, no linodes, and the goal of today's exercise is to make linodes using Crossplane. And what that means is using kubectl. Now, I don't want to roll the dice too hard and end up with a failed demo. So I am going to refer to commits that I've already made, and I'm going to walk you through that. All right. So I can also start with a README that I have. I'm also like in isolation right now. I wish I had somebody talking in my ear to tell me things that I'm forgetting. So that's what the chat is for. If there's anything you're wondering, anything you want me to mention, say it in Slack, and somebody will get to you, or say it in YouTube. Roll those dice. All right, here we go. Well, we'll see. Hopefully something breaks and I've got to like open the hood. So roughly, this is stuff I've already kind of gone over. This is what and why for a linode stack. Now, KubeBuilder 2 has made a bunch of improvements. I can't really speak for all of the KubeBuilder changes. I just know that the experience is simplified, and that's what I use to start this linode stack. So what that ends up looking like is this. I'll do things in maybe in a disposable directory for a little bit. I don't want to spend too much time doing this because I want to get to the nitty-gritty. So what we've got here, making a Git project. I'm going to skip that part. We're going to live on the edge. And going to create a stack. Or we're going to create a KubeBuilder controller. Be called 2. Get those nice Go modules, saving us all from vendor directories. All right, so KubeBuilder did something, and it tells us the next thing to do is to create an API. But let's see what they put in place here. And this is also represented by the first commit on my repo, is the combination of this KubeBuilder init and the KubeBuilder create API. By the repo, I mean this github.com/display/stack_linode demo, not stack linode 2. So let's see, what did they give us? They gave us nothing. They gave us a main.go. There's no Go code in here other than main.go. This is one of the things I'll end up coding things inside of Vim down in this little tiny terminal section. No, I didn't have to do anything special. Jared asks, didn't have to do anything special to get Go modules working in VS Code, and I haven't. I think I know what he's talking about. Sometimes the you'll get things where maybe some function, it can't follow it through, or it thinks it's undefined. I've had that before. I am not having that in this project. I'm not sure why, but it did just work. So this is all you get. You get a controller that does nothing. So now we move on to the next step that they told us, which was to create an API. With Crossplane, you want to create a provider, which is how Crossplane is going to get all of your client details for your client API. So your API token, if there's like a default region, if there's a default project that you need to use in your cloud provider, or maybe it's not a cloud provider. Maybe it is. Maybe it's a stack that calls your local pizza delivery place, and your provider needs a phone number. You know, any sort of high level API configuration. That's what a provider is going to set in place. It's now like a token. It's not going to store a token itself. You wouldn't want to put it in the provider. You want to take advantage of Kubernetes secrets management, but a provider has a reference to the secret. So when we have this provider, let's take a look at what they've done here. This is just Kube Builder in action. I haven't done anything Crossplane specific yet. Okay, so they've defined a provider spec, a provider status. I do have a provider loaded right now. Unless I deleted it, that's going to be fun. Okay, so what you can see in this provider, taking advantage of that kubectl-A to list things in all namespaces and -o YAML because it's just it's easier to read maybe than the columnar output. So the features that we need here are this. We need this credential secret ref. This is how this provider is going to know what secret to read to get my API token out of. At this point, I could shift over to my cake already baked in the oven. And so we'd be down here at right about here. And we can just forget about this. Code something real. All right. We're not really going to code anything. We're just going to watch. So another step that I took here was that the provider's job is to connect the client, to connect to the client API and configure that properly. So I did need to create a client. And for Linode, the client ends up looking like this. Pretty straightforward. This grabbing a Linode token is something that is pretty much universal for anything that's using a Linode API. I don't know that it would really make sense in this environment to tell your stack pod or your stack deployment to have this environment variable set as opposed to using secret, but I just copied it in out of habit. So this would read, this client will take a secret and it will return back a Linode Go client object. Nothing fancy. And then the actual provider itself it's all it's interested in is that secret. You'll notice that with the provider, I think this might be a step or two before I added some Crossplane runtime specifics that you'll see added on to this file in a few more commits. But you'll notice that there is no controller here, and that's because the provider is just a piece of data. It's just a Kubernetes resource. Nothing acts on it. When a stack managed resource instance is created, it will refer to the provider that it wants to use, and so it's used indirectly. Crossplane runtime will take advantage of that provider reference, and it will hand back the client object to your API. Any comments? No comments. All right. And so let's hop through history again. Nothing's changed here. Okay, so I expected something changed, but I didn't find it. All right, so and where you can find all of this referenced is in these docs, these wonderful, wonderful docs that Nick Cope created. I'm sure with help from other members of the team. Probably giving him too much credit, but he helped me with a problem last night, so he deserves it. There you go. So yes, this is just as simple as the provider spec ought be. And yeah, get checkout approach to coding. This is my new coding style. Rather than typing things live, I just switch ovens in the kitchen and I open them at different phases. Right. So implement Linode instance controller using shared reconciler. All right, that's the fun part. Let's get to that. So there was one more step that I'm jumping over, which is where I did the where I created the API controller, or where I created the where I created the actual instance API. So once we have a provider, we need to do something useful with that provider. So we're going to create a controller for Linode instances. That's not that. That's this one. Sorry. Instances. And so we could get a controller built for us by QBuilder, but that controller doesn't really fit the Crossplane runtime pattern. So we're just going to skip that part, and we're going to do that ourselves. And again, you will find that it is documented. It is documented how to make one of these controllers. It's in here, trust me. There's I linked to it somewhere else. I'll find it. Not now though. All right. So get to the right commit. So what we'll have done is we'll have added a Linode instance type, and we'll have created a controller for it. And then we'll plop into that controller all of the things that Crossplane runtime expects to have, which are documented in that page. But if you're doing a play-by-play of my commits, and I hope they clean up these commits to make it even more obvious, where the distinction was, where the different thought train was, where the different, this is what QBuilder gave me, and now this is what Crossplane says I need to do. Let me implement that, and to try to put all that in bite-sized pieces so that it's not just a wall of code that you're staring at and you're trying to figure out what's missing. I had a few of these what's missings, and I hope to point those out in this README MD, along with the reasoning behind that. Because when you have something very subtle, like you forgot to add a QBuilder status annotation, and your provider explodes, it's kind of hard to figure things out. I had another problem last night where QBuilder will start with an empty schema if you use scheme.newScheme, I believe, as opposed to scheme.schemeBuilder, and use a scheme builder object to add more schemes. So I had this problem last night where my secrets, my provider couldn't read secrets. It didn't know what secrets were, which is unusual, and that's the kind of stuff we like to uncover here. We'll hit it first, so you don't have to. That's our slogan, 2020. All right. So let me jump ahead. Let me jump ahead to master. And let me do a little file navigation, if you will. So I've implemented the instance parameters, and I've separated them out from the spec just because it makes it sort of easier to look at. I don't think there's any strong change or benefit to this. And the instance parameters that are necessary to boot a Linode, you don't need a label, you don't need an image, but without an image, you don't have a bootable Linode, so I will be taking advantage of that. Authorized users is a field that lets you put in your Linode username, and any SSH keys that you have associated with your user account will automatically be thrown into root's SSH authorized keys file. So we're going to take advantage of that so that we can actually SSH into the machine. I don't know if we'll actually SSH into it, but hypothetically we could. You do need a region because where is your Linode going to come up? And you need an instance type. And I'm just going to be using nanodes because they are cheap and small and fast. So there's a status. This is a little bit of inception. So we've got an instance status who is going to have a status field. And one of the decisions that you're making when you're writing a stack, I guess, is how you want to represent those fields. So Linode doesn't have a, when you create an instance, you can't create it with status of powered on or shut down. You create it and there's a booted flag. So if I wanted to represent the API faithfully, I would have booted here, and it would be a bool, and it's actually the Linode Go driver takes it as a pointer to a bool because there's a default behavior, and the Go driver doesn't want to set an opinion. It wants you to be able to take advantage of whatever the API's default behavior is. But in this case, I've opted to implement something that the API itself does not do, which is if you create an instance with a status of powered on or running or offline, then it will, when diffing the state of the instance, it will decide if it needs to shut it down or turn it on based on that status. The instance status, these are the things that are returned from Linode, and we stash those in the instance record. And this is a very limited view of it, just enough fields to be useful. You'll also notice I'm taking advantage of a bunch of cube builder annotations. The optional ones are just sort of hiding some of these fields. I'm also taking advantage of print columns so that when I do something like kubectl get, you can see a few more details about the instance. So let's run this. There's a few things that I've got tucked away that I will put into the README file. I'll make mention of them anyway, but they are some additional YAML files. So I'm creating a Linode namespace to run this stack in. I am creating a provider, and my provider needs to reference a secret, and you don't get to see the real secret, but you want to put a base 64 encoded version of your API token there. And then to actually provision an instance, I've got the spec filled out for an Alpine booting teeny tiny Linode that will be automatically deleted if this Kubernetes object is deleted using a reclaim policy of delete. And it's going to reference that provider that I put my secret in, this one. And it's going to write connection secrets to ref. Now that field, I don't know exactly what connection secrets make sense with a Linode VM. VMs aren't something that have traditionally been in Crossplane. Dan has, in working with his packet stack, found that it would be useful if there was a resource claim type and a portable resource class for VMs. And even though Packet doesn't offer VMs, it probably the idea is common between VMs and the bare hardware here, or the bare machine, yes, bare hardware that we're calling it. So look forward to being able to use resource claims in the future for handling VMs and portable resource classes. So let's see what happens. Let's see if this explodes or what. Yeah, that's what happens when you leave it on overnight. I'm not too worried about that. Another thing that I think is worth showing off is my my debug profile. So I'm running kind locally, and kind, if you reboot it, you lose your cluster. I haven't rebooted. I kind of wanted to, for the sake of this, destroy my cluster and bring up a new one, but I don't have faith in the demo gods. And so let's see what we have right now. Kind get clusters. Just have the default kind cluster. My kind config is right there. So my cube config is pointing to kind, and my debugger will use that, which is necessary when you're running a controller. It needs a cube config value. It needs to know what cluster it's going to be talking to, especially when you're debugging it. I provided a namespace. I don't know that this is actually necessary in this case, but I did provide one, and I set a Linode Go specific variable that causes all of the HTTP traffic to be dumped, minus the tokens. All right, so that's my debug. And let's see, I don't know what I changed in here. Hopefully nothing real. Okay, do that. Where are we at? Okay. So I can run this with go run main.go. I have to set the environment variable, but since I have my debugger already wired up, let's reuse that. And first, let's find out what I've already created in kubectl. When you've made this controller the way that I have, using Cube Builder, and then you've put in your Crossplane runtime pieces, you can still take advantage of Cube Builder's make files. So I've got tab completion on my make, and so what we have here is we've got make generate is what I'm interested in right now. Make sure I've got the latest version of my spec and my status in my cluster. I can do make install. So this updates the CRD for these instance types in my cluster. And I can see that by doing get CRD. I already have Crossplane installed in this cluster. If you don't have Crossplane installed in your cluster, you can find those instructions linked in our documentation. But if you're working with kind, you can take advantage of this script here. And you can use kind up, and it will create a cluster for you. And then you can do helm install, and it will install Crossplane into there. I believe you might have to do a make first so that you have a local image of your Crossplane. Phil's saying Packet's bare metal cloud with an IaaS API, just like IaaS for VMs. Yes. Phil knows his products. And there are some distinguishing features between VM providers and bare metal. Things that may not apply, but I don't exactly know what they are. I assume with bare metal, as with VMs, you can choose a different size of hardware or a different size of VM. I assume you can choose your base OS and what your disk configuration should be. Perhaps you get options to configure the users. Perhaps you get options to configure the networking behind that VM or that bare hardware. So there's a lot of overlap, and that's where this portable resource class will be able to work for both environments, hopefully. And then, of course, there's going to be early provisioning steps, too. That's something I left out of this Linode demo stack, is I didn't really provide a way to use take advantage of Cloud Init or in Linode stack scripts I have a stack script that implements cloud in it, but that would be useful. So you've brought up a VM. The first thing you're probably going to want to do is provision it with something. I left that out of this. That is something for the viewer to figure out and do. And pull requests are welcome. Open an issue, and we'll see what happens. I really opened this whole project just so that people could learn from it, how to implement stack. This is probably not the best example of what a crossplane stack should look like, but we hope to see stacks for all providers soon, and we're looking for the community to provide those as much as possible. And Hacktoberfest is coming up, so we'll have to see if we can get involved in that. Funny talking about a DigitalOcean sponsored event on a Linode related stream. So I already have Crossplane running. I already have everything that I need except for this controller running. I did want to show that I had the CRD installed for this instance right there. And if you like reading YAML, you can see that all the details of this stack are defined in here. Or of this stack, I'm calling it a stack, but of this controller, all of the spec and status fields are defined in this CRD. And so let's start running it. Got my debugger. That's not my debugger. Got my debugger. And want to make sure I'm starting somewhat clean. kubectl delete providers all in all namespaces. Goodbye. Delete instances. None. Delete. I won't delete the Linode info namespace. That one's kind of obvious. Anything else? Nope. I'm going to keep my secret in place. Make sure you put a secret in when you do this yourself. So let's run it. I have some breakpoints. We'll probably bump into them. And we won't bump into that one. All right, so it's running. And now let's add my Linode provider. I already put the namespace in this file, so we should be good there. Then the Linode info dev is pointing at my secret. And now we're going to create an instance. And we do recall all of the fields that were inside of that instance. Code. You need a way to open VS Code from the terminal. That's it. These are all the fields. Let's do this. Okay. And now we can see, well, there's some explosions. Hopefully nothing serious. It's secret 2. I think that's compiler operation can build instances modified. What happens when you commit a few things and then you don't actually test it. All right, so that looks okay. Let's try this. All right, so that's it. kubectl get instances. It shows it's provisioning. The Linode CLI shows that it's already running, but our reconcile loop is taking about, it adjusts based on what's going on, but I think it's about 30 seconds before we'll see it pick up on that change, unless it's exploding, unless my update broken and the demo gods are laughing at me. They laugh at my puny attempts to not have to write any actual code. Okay, cool. The status is updated. They both reflect that the Linode is running. So one of the pieces that I implemented in here in this Linode controller, I didn't really show this yet, but this is Once you have your instance type, your spec, and your status defined, you do need a controller to do anything useful with it. And the controller runtime pattern is such where you define just basically 4 methods: connect, which is how to get to your your client API object, and observe, which is how to look at one of the records of the type that you're operating on. And yeah, there's some excitement. Woo! Jared Watts says, "Yay! kubectl create linode.yaml." Dash f. Don't forget the dash f. So observe is this is stolen right out of the docs. How useful these docs are. It will see the state of, it will get the instance, and it will decide what needs to be done based on that. If the status needs to be updated, it will do the updating. If something needs to be updated, it will flag that an update needs to happen. So basically, I've only implemented one update field, and that's the status of the power. And this is a nice little bit of Boolean. You can see also I have, Jared knows the name of this font, but Cascadia. I have the Cascadia font with ligatures support enabled. So my not equals is extra cool. So are my ands. So it has to implement a create function, and it has to implement a delete and an update function. So the only thing that I'm really focused on in this is creating an instance with enough of the fields that the instance will boot. And I am honoring the phase of boot status that a person wants when they create this instance. If they say they want it to be running, or if they want it to be offline. And then in the update, that's the only update thing. That's the only thing I worry about updating if I actually apply. And when you delete an instance, you delete an instance. Again, that's based on the reclaim policy, which I have in this file set as reclaim or as delete. So we have an instance, right? Reload. I think they timed out on my inactivity there. We have an instance. Oops, Bob became an admin today. Bob deleted our instance. Bob, why did you delete our instance, Bob? Now let's see what happens. We've angered Crossplane. So Crossplane doesn't know this has happened yet. He's gonna tune in soon, and he'll observe that that instance has been deleted. Great time to talk to you all individually, one-on-one. He'll gives some kind of yeah, never trust Bob. He'll give some kind of emojis that I'm not seeing. Might be a Mac versus Linux thing. Yeah, never trust a Bob. All right, so we're waiting to see this status get reflected here, unless I've broken things, which is not beyond belief. But this totally worked last night. Ah, there we are. See, I just had to like flip tabs and lose faith. So now they're both in the state of provisioning. The Linode has moved on a little bit further. It's booting. Kubernetes is seeing that. Also, you'll notice that those print columns that I added, this is my kubectl command. Kubectl get instances. I am doing -o wide, which is showing me more than the normal fields, which is I think name and age. So so this is kind of similar to the output that you would expect from the Linode CLI. So booting, running, okay, he's going to get this thing running. While he's getting this thing running, let's mess with him. And let's change the status from running to offline. Now, if I put garbage here, I do want to think that I put in the I defined the enum type for this. I did. So if I put garbage in here, oh, well, I haven't applied it yet. Should be one of offline or running. Okay, if I did a kubectl edit, that's where the fun happens. If I do an edit, and I find that running, and I change that to garbage. Hey, he didn't like me for a different reason. When you do an edit, you have to specify your namespace, even though the file has a namespace in it. I don't understand that, but I encountered that last night too. So running is going to be garbage. I'm running down in 9 minutes, so you gotta be quick. So look, it aborted. It said it wasn't valid. So I gotta go find my, I don't think the garbage is still here. It is. So we want it to be offline. Accepts it. And what you'll see happening is that the instance will get offlined. So running, that is the status that was there last time. It did observe that I wanted, as soon as I did that apply, the update was triggered. It knows that it wants this thing to be offline. The Linode is going offline. And kubectl, well, the state is getting updated in Kubernetes with all these intermediate steps, which my logic just ignores. I'm only interested in offline and running. So there you have it. There's one more thing, I guess, that's worth showing, and that's deleting the instance. So let's wait for this thing. They're both, he's in shutting down. He'll pick up on the fact that if I can repeat my previous steps, just switching tabs was always enough for it to figure it out. Hey, oh, there's updates are happening. Nope, hasn't happened yet, but it will happen. It'll happen soon for the rest of our lives. So this shutting down will become an offline. Have faith. And there we go. Offline, offline, state matches. Now we're going to anger it again, and we're going to delete that instance. kubectl get instances. Just want to show what this looks like. That's the bare output. I can do my -o wide and see all of my fields, and I can do a kubectl delete in that namespace. And instances and the name of the instance, which is just instance. So much easier to do delete-f the file, but this works too. Okay, so if we do our watch command again, it's already gone. I tried to catch it last night too, and I couldn't catch it. It just happens very, very instantly. So the Linode is gone, and you can see that did all the things. So in the remaining 7 minutes, if there are any questions, go ahead and ask them. And if there aren't any questions, I'm going to just walk through a few more things I wanted to point out about this stack. So what you'll notice in some of the more advanced, the more thought out, the ones that weren't prepared in a week stacks, is that they implement Crossplane's resource claims. They implement various resource claim types and portable resource classes. So what that looks like is you have a cache compute. So there would ideally be a type for there would be a class for VMs in Crossplane itself, and this would be a portable resource class. And with that, you'd be able to say, I want to create a VM instance, and you would have a default class defined. You wouldn't say whether it was through Packet or whether it was through Linode or DigitalOcean. And when you create an instance of that, when you create a Kubernetes record of that instance, you would get a VM through whatever provider your ops team decided was the provider to use. We'd have to implement a few more things in this Linode stack to get that kind of behavior. We would have to define a resource claim type and a non-portable resource class. And I want to point you to what those look like for reference. Stepping in the wrong directory. So this is a GKE compute. I'm not sure if this is the generic class for this, or if it's the actual instance. It is the actual instance. The controller is handling. I don't know. I'll update my README, and you'll get all the facts in there. If anybody wants to update puts more accurate details in the chat, I'll let that happen. Another project I want to point out was that Nick Cope is working on this thing called Angry Jet, which will hopefully automate some of the steps involved in converting a project from straight cube builder to a Crossplane runtime happy controller project. And I have several commits in here that are very boilerplate that you would do on any stack. And that project aims to get rid of that boilerplate. I don't know if this is the commit that introduced it, but no, it's not. So I'm pointing it the wrong direction. Register, implement instance control, shared reconcile here. Nope, not that one. It was a previous commit. What else did I want to point you at? These are the types. These are the resource classes that Crossplane knows about now. So you ideally want to make your stack implement non-portable resource classes for these and resource claims that match these types. Kubernetes cluster, for example. And speaking of Kubernetes clusters, Linode has a Kubernetes engine coming out soon. Looking forward to that. And things like that and bare metal on Linode will make stack more interesting in Crossplane, because you'll have access to more types of resources that you can abstract away. And once you have Linode support for those things, then you can have a stack that implements all those features on DigitalOcean or on Linode or on Packet, and just toggle a provider reference and bring up that instance somewhere else, or bring up that Kubernetes cluster somewhere else. So that's about it on time. Thanks for hanging out. Thanks for watching me create and destroy Linodes. The next episode of TBS will be on October 10th at the same time, 9 Pacific, 12 Eastern. We have a community meeting happening October 1st. Those happen at, I believe, also at 9 Pacific. But you can check in our Crossplane Slack or on our website for details on that. And let's see, am I forgetting anything else? No, I think I came pretty close to covering all the things I wanted to. I will update the notes on the Crossplane TBS Git repo with the README that I went through here. I'm going to touch on that a lot more so that you can follow along with all of the commits. And hopefully with our stacks, I didn't actually get to run through the stack CLI, but with the stack CLI, you can package up the stack, and then you can make it so that you can deploy your Linode stack without having to do things from the Git project like I did, using Go Run or using a debugger. Instead, you would just do kubectl create, and you would give it a stack install file or a cluster stack install file. But I didn't get into that. Sorry. It is included in the repo. So the README will be updated with it. So that's time. Thanks again, and tune in 10:10. Thanks for all the lively chat. Bye.